Hello and welcome to another AB Computer Science video. In this video we're going to finish up our discussion on inheritance in Java. We'll do one small example to represent the final benefit really that inheritance gives us, and this is the term polymorphism. If you think about the word polymorphism, poly means many, and morph or morphic or morphism means shapes or changes in shapes. To morph something is to change something. And so the idea is that we will gain the ability to keep different types of objects of specific classes under one label because of this inheritance hierarchy. So in our example, we have person classes, and students are persons, and teachers are persons, and grade leads are teachers, which makes them persons. And that's all well and good. And we've seen in our example, we've made individual types, variables of those types, and we could do that, and that's great. But a more realistic scenario might be, well, our system now that we have students and teachers and grade leads, we might want to represent a school system with many, many people. And there might be hundreds of people, and we don't know necessarily what they are until the program is running. And so if I want to keep track of students and teachers and grade leads, one approach is to keep separate, for example, lists. Maybe we're using array lists. I could keep separate lists for different people, and then I have to determine, well, was a student given to me, was a teacher given to me, was a grade lead, and add them to the appropriate list. But that's kind of limited because the problem becomes, well, every time a new type gets created, we may have to make another list and check that type and so on. And so the benefit of polymorphism says, instead, if we make our list or our variable of the broadest type possible, basically the highest parent that we think is reasonable, we can put any object of any subclass or child class within that variable. And that's a pretty big deal, because then we don't have to worry about, well, what specific type of person are you? What specific type of teacher are you? Are you a regular teacher? Are you a grade lead? And so on. That's a real powerful example. So let's try doing that. So I'm going to go out of my way to start off. I'm going to erase these prints in my main, and we'll start off by first making a list, an array list of persons. And so we'll say person, or we'll call it school because it's going to represent all the schools. So we'll make a new array list. And so there's our list. We have to import to make sure our array list works. And there's our array list of persons. Now again, you might think, well, and it's not wrong, because for this whole year we've said, well, variables must match the type, the object must match the type of the variable. And that's true. But with inheritance, we also have the ability to say, well, a teacher is a person, therefore it does match, even though it's a more specific type of person. And a student is a person, even though a student is a more specific type of person. So this means that I can say school.add, and I'm going to go ahead and put S1, and there's no error. And this may seem confusing because this says accept person objects, but I've passed in a student object. But students are persons through inheritance, therefore this is not a problem. So we can say this rule will say polymorphism allows specific type objects to be stored in variables that have a superclass type. And this means that it's not just direct superclasses, but anywhere in the hierarchy. So again, in our diagram of grade lead, teacher, and student and person, all three of those types could fit under person because they're all under the umbrella of what a person is. And we can prove this by adding those things. So we can say school.add T1 and school.add G1. And notice now there are no errors because all of those are persons. Now again, this kind of seems odd, and there is one very important limitation. And again, we have to kind of visualize as we make variables, what we're doing is especially when it comes to inheritance, we're kind of putting a scope, the view or like a filter of what we can see. So grade lead G1 is a grade lead, so we can see all the grade lead information. But if I went like this, another ability we can do is we can say something like this, and this may seem odd. Person P2 is equal to a new grade lead, and we'll put I don't know, we'll just put a name, and we'll just put an age, and we'll say English, and this is a 11th grade lead. Okay, there it is. And so there's our grade lead, and notice there's no error. And this seems very odd because we've always been required to match the constructor to the variable type. And this is a big difference because even though grade lead is not the same constructor as the person class, it is inherited through this chain of our classes. A grade lead is a teacher is a person, and therefore this is allowed. So the rule is, right, a generic or a type, a variable, can be assigned any class that inherits from it. I'll go ahead and say directly or indirectly. It's important. So this is kind of an indirect inheritance through multiple layers. And so this is wonderful. And then now I can say simply school.add P2. And now if I ask how many grade leads are, the answer is 2. Now there is still a limitation because now if I attempt to do this, we know grade leads have the ability to add team members, right? It's a method that we created in our grade lead class, right? There it is, add team member. And then they've also inherited the ability to add students to their advisory because they are teachers and the teachers have advisory, so they could theoretically call the add advisee method. However, because P2 is of the generic type, the highest level superclass, persons do not have the ability to add advisees or team members, and therefore if I try to say P2.add member or team member, and it's not, if I put a T1, it fails, and it tells us, look, cannot find the symbol method add team member. And then the problem is we said, okay, well, we know that in RAM we will actually be creating a grade lead, but from the perspective of the compiler, it really cares about, well, what type is the variable. This is what it knows it can handle. And when the program runs, it may be correct, but the reality is from our perspective, or from the compiler's perspective, it does not know that it's actually a grade lead. It says, well, P2 is a person. That's the lens that we're looking through. That's the filter we're looking through. So if you want to see P2 as a grade lead that you know that it is, we must either cast it or make the type of the variable the correct thing, of grade lead. And this is okay. So we have to accept that, you know what, if you're going to put multiple data types in one list of the generic type, then we have to accept that we can't necessarily see all the details. So now, if I were to print out all the content of my array list, so I can say for every person, we'll say P in school, let us print their content. Again, now what methods does P have for every person in this list? Now again, some persons are students, some are teachers, and some are grade leads. But from the perspective of this loop, the content of school is a person type, and therefore only person methods can be accessed. So if I say person dot, I only have get age, get name, set age, and set name, and toString. Those are the only ones that are passed along across all levels. These are this is the only thing we can see here. And so if I want to go ahead and print out, I might be able to do this, and I'll say p.toString, and that might be okay. And let's go ahead and see what happens if I run this. We should see the toString. And what's nice, and here's where the polymorphism comes in. Even though the data types are generic, the compiler knows to call the appropriate method at the correct level. So you'll notice, actually, let's go ahead and put a print somewhere so we can see it real quick. We'll say, we'll print out something like school information. Right, so we'll say school information. Let's run it one more time. And here it is, and we can find school information. There it is. And so notice the first, even though this is a list of persons, the first P was a student, and notice the student toString was called. The second person was a teacher, T1, and notice for Jane Doe, the teacher's toString was called, and it prints out the advisory, which contains the student. And then for the third person, it was a grade lead, and notice that the grade lead's information was printed out. So the power of polymorphism is the ability to handle things generically so we don't have to rewrite our code too often, and yet still have the appropriate methods at the correct level called. If you override a method at any level of an inheritance hierarchy, that is the version that will be called if it can be found. If not, it moves up to the parent, and if the parent doesn't have it, it moves up. And if somehow nowhere in the chain the method exists, that's when you have an actual compile time error. So if I tried to call a method that didn't exist in any level, then it would fail. but the toString works for all of them. And even if we didn't implement toString, it would still have worked, because at the end of the day, object has a toString, as terrible as it is, and therefore we would have seen the object version. But there is the other gray lead, and this is another gray lead. So we have the ability to do this. This is very powerful. And still, it's not perfect. And if I wanted to call specific things, then what I could do is, instead of, let me go ahead, actually I'll print that first, but we could ask a question. We can say, we know if you're a specific type, maybe we can convert you. So let's do something specific. Let's go ahead and say, let's just ask if they're a student. So we'll say if P, and now again, that keyword that we use to determine if an object is of a particular type is instance of. So we could say if P is an instance of student, then if that's true, we know we can't call student methods just yet, but we could look at that P object through the filter of student with a new variable, call student methods through that variable on that object, and then continue to the next one. So we're going to do this. We can safely convert. We know you're a student, so I can say student s equals a student cast version of P. So now P and S refer to the same object, except one is as a filter of student, one is a filter of person. So now S has more functionality. Now I can say S dot, and actually we didn't put any other methods in student, but if we go ahead and do that, let's try to do that. Let's do something like, let's do adjust GPA. Let's do public void adjust GPA, and we'll say double ADJ, and we'll say GPA plus equals the adjustment. So there it is. And so now if I save this, now I can go back to our main and we can say s dot adjust GPA, and I'll do something like minus 0.25. So this person now has a 3.75 if they had a 4.0 originally. And so the idea is that this would not work. I could not say P dot adjust GPA because P is still through the filter, the lens of person. But if we know we can cast it safely, then we can do that, and then we can call methods to that perspective. And then back in the generic version, we can say, you know what, call your toString. So again, the benefits of polymorphism is the ability for the computer to know which version of a method to call. It knows which toString to call based on what it actually is. And I believe that the proper term is dynamic dispatch. The computer can keep generic information, but say, okay, when the time comes to call a method, what is the actual version you need? And that's an important takeaway. It's the last kind of thing. So on the AP exam, it's possible that you will receive a multiple choice question that says, okay, here is the class, and here's the inheriting class, and here's another inheriting class. If I call, you know, a variable dot method, which version is called? We have to be able to know this and create this. And so what we're gonna do now is we'll take a moment to practice this really simply with some quick examples. We don't need code to do it. We just need to understand the hierarchy to establish that. So we'll do that right now. Okay, so what we're going to do is we're going to go to our whiteboard and we're going to draw a hierarchy and just understand a quick example. So we're going to start off with a class called A, and we'll say that the class B inherits from A, the class C inherits from A, we'll say the class D inherits from B, we'll say the class E inherits from B, we'll say the class F inherits from C, and finally we'll say the class G inherits from E. So this is a pretty complex hierarchy, and of course we all know that they all, by default, inherit from object. That's the starting point. We can always assume it's true in Java. So now, what can we ask questions about? There's two aspects we need to know. When we declare a variable and assign it, are we allowed to do so? And can we safely assign a specific type to a generic type? Those are two different aspects that we need to be aware of. So here we go. Let's do something like an example. I'll do the first one. We'll say number 1, and we'll say that B. Now I'm just going to have variable names. My variable names are always going to be called X. So we'll say there's a variable called X, and it is equal to a new, and we'll say D. And there's my, we'll assume that they all have default constructors for now. So that's the first question. The second question, we'll say something like, we'll make a variable of type C, and we'll say it's equal to a new C. We'll do another question. We'll say something like A is equal to a new variable of type E. We'll do number 4. Let's try something like E is equal to a new A. And let's do another one, and we'll say that f is equal to a new c. And we'll do one more, and let's say we'll say d is equal to a new g. So now we can ask ourselves for each of these questions, are these valid or invalid? Will these cause compile time errors or exceptions? Yes or no? And it should be easy to do. We don't need to know anything about the classes. We made the assumption that they can all be created. We made the assumption they'll have default constructors. What is actually happening here? So let's look at number 1. And we're saying a variable of type B contains an object of type D. This only works if the thing that's being created is a subclass or indirect subclass of B, or the one being assigned. So is a D a B through inheritance? If we look at our diagram, a D is a direct B through inheritance, so therefore this one is a valid statement. The next one, C, is equal to a new C. Can you make a variable of type C and put it in a C variable? I mean an object of type C and put it in a C variable? The answer is yes, of course. This is the standard. This is what we normally do. So this one works out. No problem. Number 3, we create a variable of type A and we put a new E inside of it. So the question is, can you put an object of type E into a generic variable of type A? And again, the rule is E, or the thing being created, must be a subclass or indirect subclass of the type being created. And the answer is yes. E is a B is an A, therefore an E is an A. And therefore this one works out. Number 4, we have a variable of type E, and we create a new object of type A, and we try to assign it to the E. Does this work? And again, the rule is that the thing being created must be a subclass or indirect subclass of the variable being made. And the answer is this does not work because E's are B's and B's are A's, therefore E's are A's, but A's are not E's. All E's are B's, all B's are A's, but it is not true that all A's are B's, and therefore it's not true that all A's are E's. So this does not work. Number 4 would not compile. And how about number 5? F is a new C. And we can see again, we create a C object, we put it in F variable, same problem. All F's are C's, but not all C's are F's. So if you make a C, you cannot put the superclass type into the more specific type. So it's a one-directional operation. So this one also fails. And now number 6, we make a variable of type D, and we create a new G object. Can we do this? And the answer is no, because there's no direct connection between them. Yes, D's are B's, and G's are E's, and E's are B's, and therefore G's are B's. However, there is no direct connection. There is no, even though inheritance connects them, they're both the same B. The variable is a specific type D. G's are not D's in any way. Siblings or cousins or whatever you want to call them, it doesn't exist. There's no connection between them. So therefore, this one also fails to happen. Right, so this is an important aspect. And now the second half of this is, okay, this is easy to recognize whether we can construct objects and put them in generic variables. This is a pretty easy approach. The second more challenging aspect is, well, which version of a method is going to be called? So for example, let's say that A has a method called A, right? And that means that all of these inherit A. So every class now has a method called A. But let's say that C overrides A. So this is an override. And F overrides A. And then now let's look at B. B has a method called B, and then D overrides its B method and its A method. And we'll say that E has a method called E, and then G overrides its E and its A. So now, let's set up another scenario. Let's do this. We'll say number 1. Let's make a variable of type A, and we'll call it X is a new B. Oops. Actually, let me try fixing that. Okay. A new B, and then I say X dot A. The question is, which version of the A method is called? Which class's A method is called? Is it the A method? Is it the B method? Is it the D, the E, the C, the F, the G? Which version of the A method is called in number 1? If we look at this, A created the method A, and it passes along to its inheriting children. B only wrote its own B, it did not touch the A, and so therefore we can say that the version of the A method is the A version of the method, because there is no B version. If you don't have your own overridden version, you use your parent. So this call is the same as calling the A version. And this works out because A is a general type and B is a more specific type. So let's try something a little more complicated. Let's say something like, let's do a B is a new G. Can we do that? And then if I call the A method, which version is called? So first, can I make a G and put it in a B variable? And the answer is yes. Because G's are E's, E's are B's, therefore G's are B's. So this construction works out fine. And now the question is, which version of the A method is called? So the class A has it, B inherits it, E inherits that, G inherits it but overrides it. And so now in the actual call, which version is called? And the answer is the G version. If you override your version, the computer with polymorphism will say, I will call the most specific version of the method I can, and if not, I'll fall back onto the parent. So it'll say, well, okay, A is overridden, therefore this is the G version, because even though the variable's of type B, the object is a G, and therefore, and G has an overridden version of that method, therefore the G version is called. Now, if I had done something like an E, then it would say, well, E's don't have their own A, B's don't have their own A, and therefore the A version is called. So this version is the G version. Let's do one more problem. Hopefully we can see it's pretty easy to know. If you know the hierarchy and you know what's overridden, then it's pretty easy to establish, are you allowed to do it and which version is called. So let's do one more. Let's do, let's say A. Let's make an A variable, and let's make it a new E. And let's do x dot E. And so now the question is, can we do this first line? Can we construct it in this way? And then can we call this method? And if so, what is the version that is called? So here we go. We say, well, A is a new E. E's are B's. B's are A's. Therefore, E's are A's. So the construction works out fine. And then now x dot E. X is of type A. Even though we know it's an E object, the problem is the variable type controls what's allowed to be called. The construction tells us which version, if there is a call, is going to happen. So even though this is an E, and E's have E methods, X is not the filter of E, and therefore this is an error. We cannot call this method. This fails here because A's do not have an E method. Which is okay, call the A method, no, but you don't, the E method, but you don't have one, so it fails. So this one does not work, right? And that's a problem. Now, if I had done this, we'll do one more. If I had said, let's try something like, let's do B, X is a new D, and I say X dot B. Now the first question is, can we construct this? Can a D be made into a B variable? The answer is yes, because D's are B's through inheritance, and therefore this line works. And then X dot B. Can we even call B? The answer is yes, because D's have a B method inherited, and they overrode it. So the actual version that's called is the D version, right? So again, these are two aspects of the same problem. Can you even put a specific object into a generic variable? And then once you can you call a method? And if so, is there a version? Which version would be called if there are multiple versions, right? So if you can answer these questions, then you're in good shape for inheritance overall. Coding it is one thing. Knowing the keywords, extends, and overriding and the notation is not too complicated. But really, the key takeaway is, can you understand the hierarchy and what it means for what code you can write? So I'll stop the video here. We have one more topic. The last discussion we'll have is on recursion, and that's a very important tool, challenging tool, but really one that's interesting and fun to use if you know it well. So we'll see you in the next video and hopefully finish up the class in a strong manner.